In this session, I'm going to talk about stopping sight distance. But before that, I want to review the things what we have discussed in the last session. In the last session, we have talked about the various geometrical elements like friction, skid resistance, unevenness, undulations, what is a carriageway, what is the width of a single lane road, and then what we have seen, what is a shoulder, what is the objective of a median. We have seen all those things. But all those things what we have discussed in the last session can be clubbed into one picture, and let's see what is that picture. First, there would be a carriageway. And what is a carriageway? Carriageway is nothing but the path over which the vehicles are being carried. The way over which the vehicles will be moving, will be carried, is called as a carriageway, right? Now, basically this is nothing but our road, and this road also contains a median if the road width is more, right? So I'm not specially indicating that here. Now, besides the roads, besides the carriageway, you will be having shoulder, right? So adjacent to the carriageway, on both the sides, you will be having a shoulder. And what is the purpose of shoulder? We have already discussed this. The purpose of shoulder is to provide a place for emergency breakdown of vehicles, right? Now, after this shoulder, we have road margins. Road margins. Right? Now, after this road margins, you will be having road boundary. RB. So here also this is road boundary, right? And after the road boundary, there will be a building line. So this is my building line. And common sense, what does this building line represent? So if at all, if you want to do any constructions in this particular region, all these constructions, all the buildings, what you are going to construct should be after this line only. After this line only. This is what it means, building line. A very simple, self-explanatory term, right? And the last one is control line. Same, here also control line. Right? And what is this control line? So the highway authority or the road authority has full right to do whatever they want up to this control lines. So if they want to further extend that particular road, they can go for the extension. They can do the demolitions of the buildings also, even if they exist up to this particular lines, control lines. Any modification or any things, whatever the road authority want to do, can do up to these two lines. That is control lines, right? Now, this carriageway plus shoulder, this carriageway and shoulder, both will be at the same height. Both will be at the same level. That's why they are called as carriageway plus shoulder is called as formation width or roadway width. Formation or roadway width, because both the roads and the shoulder will be having almost same height. So that's why it is called as formation or roadway width. Now, what is this road margin? What will be provided in this road margins? Now, if you want to provide any facilities on this particular road, like footpaths, bus stops, parking lanes, etc., then you can provide all those facilities in this road margins, right? Now, road margins plus formation width, that is distance between two road boundaries lines, is called as right of way. So formation width plus road margins is called as right of way. Now this is an important 1 mark bit. They have asked it one time. What is right of way? Now, right of way is the minimum land that is to be acquired before starting any road construction. So if you want to do any road construction, the first thing is to go for land acquisition, and how much land is to be acquired is minimum this much. So the minimum land that is to be acquired for doing any road construction is right of way. And for a national highway or a state highway, generally this right of way that we acquire for a national highway or a state highway is around 45 meters. Is around 45 meters, right? Now, we have already seen what is building line, and generally the distance between the two building lines is around 80 meters, right? And control line, I have discussed it already, and generally the distance between two control lines is around 150 meters, right? So all the things that are shown on a road that will be available on the road and adjacent to the road can be seen in this one single picture, right? So we can note it down for 1 minute. Yeah. So that's about the basics of geometry design. So now we'll start with the design of elements on the road. And the first element that should be considered in the roads is side distances. Now we have 3 different types of side distances. So the first element is side distance. Now what is side distance? Now it's a very simple term. Sight means seeing, right? Seeing or nothing but visible, right or not? So sight is seeing, that is visibility, and distance. Now I combine these two things. The minimum distance visible to the driver at any point of the journey is called as sight distance. So if the driver is moving, then the minimum distance that is visible to the driver on his journey, on his movement, is called as sight distance. Now we have two very important assumptions here. It's a very frequently asked bit in most of the exams, very repeatedly asked. We have two main assumptions here. Now, what I said, the minimum distance visible to the driver. Now, the distance visible to the driver depends on the height of the driver's eye level, right? So if I'm standing like this, I can see, I can cover more distance. Now, if I sit, if my height of the eye level decreases, the maximum distance what I can see will be decreased, right? So the major element which is influencing the sight distance will be the driver's eye height. Now, different persons will be having different heights. So again, different objects, different cars or different two-wheelers or different lorries or trucks moving on the road will be having different seating heights. So how much should I consider for the driver's height level? So that is why we make an assumption here. The first assumption, height of driver's eye level. Height of driver's eye level. And I indicate with capital H here. Height of driver's eye level is indicated with capital H. And this is 1.2 meters as per IRC. IRC is Indian Road Congress, right? So height of driver's eye level is assumed as 1.2 meters. Now, next one. When you're traveling on a road, we sometimes apply a brake. And when do we apply a brake? If there is an obstruction. So what is an obstruction? For example, if this pen is on the road surface, will you apply a brake for this pen? No, right? Why won't you apply a brake for this pen? Because your vehicle can easily move over it. Your vehicle can easily get over it, climb over it. Because this pen, so that's why this pen is not an obstruction for you. So what is an obstruction? Any object over which your vehicle can't climb, over which your vehicle can't move, can be called as an obstruction, right? So what is that height over which your vehicle can't climb? That is the second assumption we make here. So height of obstruction. It is indicated with the small h. So height of obstruction is 0.15 meter or 15 centimeters as per IRC. Means if the height of the object is more than 15 centimeters, it is difficult for the vehicle to move over it. So that's why we treat that object height of 15 centimeters is an obstruction. So if any object which is more than 15 centimeters is there on the road, that will be an obstruction. So you need to apply a brake for that, right? So these two are the very important 1 mark bits that was asked in most of the exams. Now, This side distances can be of four types. First one is stopping side distance. Second one is overtaking side distance. Third one is intermediate side distance. And fourth one is headlight side distance. So there are four types of side distances: SSD, OSD, ISD, and HLSD. Right? So let me start with the first type, that is stopping side distance. That is the present topic for the session. Stopping side distance, SSD. Now, let me take a figure and then explain this stopping side distance here. Now, from here onwards, in transportation engineering, there are two types of V's. V is nothing but design speed. So this V can be capital V, or this V can be of small v. If I write capital V, that means the design speed is in kmph. And if I write small v, the design speed is in meter per second. Now, when will I write capital V and when will I write small v? If I write capital V, that means that is an empirical formula, means no logics, that is based on an observation. So you will be taking a road, you will carry out some exercises on this. From that exercises, you will be doing back calculations and developing an equation. That's called an empirical equation, empirical formula. So there will not be any logic. So you should use the same units which were given in that formula. Okay. And if I'm going to do any derivation, any logic, then I'll be using small v. So capital V is design speed in kmph and small v is in meter per second. In most of the transportation engineering, I'll be using small v only. If I use capital V, then I'll be stressing you at that particular point. Okay. So let me take a figure here and see. So there is a vehicle moving on this road. Let us say the speed, or let us assume that this vehicle is traveling at maximum speed. This vehicle is traveling at maximum speed. Worst case, we always design for worst case, right? So for a worst condition, as a worst condition, you assume that this vehicle is traveling with maximum speed. And what is maximum speed? And maximum speed is nothing but design speed. So let us say that this vehicle is traveling with maximum speed, and I'm going to derive this. So I've assumed that this car is traveling with v meter per second. I've used small v, right? Now, yeah. So this vehicle is traveling on a road with design speed of v meter per second. At some point of time, he has seen an object here. He has seen an object here. Now, he was traveling and he has seen an object here. Now, he will think whether this object is an obstruction or not. He will think whether this object is an obstruction or not. And when do you call it as an obstruction? If this object is more than 15 centimeters, and if your vehicle can't climb over it, can't escape from this object, you will call that as an obstruction. So to decide whether your object is an obstruction or not, you need to think. The driver need to think, right? So I assume that myself, I am traveling in this car. So first I have seen this object, then I am assuming and I'm thinking, I'm analyzing this situation whether this object is an obstruction or not. If that object is not an obstruction, I will not apply any brake and I'll move on. Now, if my mind says that this object is an obstruction, then what will I do? I will apply my brake and I will stop my vehicle, right? So here there is an obstruction, here there is an object, right? So first I have seen this object, and please be careful here. I am in this car. I have seen this object. Now, when I am seeing this object and when I am analyzing that this object is an obstruction or not, have I applied any brake, or do you apply any brake when you are seeing that object? No, right? So your vehicle will be moving with the same speed of v meter per second. So I'm going on thinking, and when I am thinking, your vehicle will be in the moving condition. I will be in the moving condition only in the car. So after coming from here to here, means after some 2 to 3 seconds of my time, I came to conclusion that this object is going to be an obstruction. If I don't apply my brake, it will lead to an accident. That is what I came to know after thinking about this object. So as I thought that this would be an obstruction, then I have applied my brake here. And stopped my vehicle before hitting it, without hitting it. So here the vehicle has been stopped. So what would be the velocity of my car? Obviously the vehicle has been stopped. So velocity would be 0. So now I'm dividing this figure into 2 segments. This is my first segment. And this is my second segment. Now, what happened in this first part and what happened in the second part? If you see carefully, in the first part, you were just looking at that object and analyzing that object, whether it is an obstruction or not. And you have not applied any brake when you are thinking about it. So you are traveling with the same speed. Now, as you are traveling this distance, when you are analyzing that object, I call this as lag distance. So what is lag distance? How can I define it? The distance moved by the vehicle during what time? During your thinking time, whether this is an obstruction or not. And that time is called as reaction time. And how much is the reaction time? Again, this is a very important 1 mark bit, direct bit. Of course, if you not got any value in the problems, you should take that value only. As per IRC, the reaction time of the driver to be taken is 2.5 seconds. That's a very important value. As per IRC, the reaction time of the driver is 2.5 seconds. Now, what happens in that reaction time of 2.5 seconds can be explained with the help of PU theory. PIEV theory. P is for perception. I is intellection. E is emotion. V is volition. So what happens in that reaction time of 2.5 seconds can be explained with the help of this theory: perception, intellection, emotion, and volition. Now, what is perception? Perception means feeling the obstruction. And how are you feeling the obstruction? By looking through your eyes. Similarly, when you're traveling on a road, somebody may give horn to you. So that means he wants to cross for his path, you were an obstruction, right? So the dangerous situations on the road can be perceived either by looking or by your ears. So whatever you see or whatever you hear goes to your brain. So the time taken by perception means the time taken by eyes or ears to travel to your brain is called as perception time. Okay? Now, once the things goes to your brain starts recollecting it. Your brain starts analyzing that situation, right? Your brain will work what to do now, right? So the time taken by the brain to analyze that particular situation is called as intellection time. Now, if that situation is dangerous, you may feel worried, you may feel some tensed, right? So there will be some wastage of time in expressing your emotion about that situation. Now, volition. Volition means the time taken for the final step of action. Okay? The time taken for the final step of action is called as volition. Now, for example, my brain said that this is going to be an obstruction. So my brain says me to apply a brake. But who will apply the brake? Either my hands or my leg will apply the brake, right? So the time taken by your brain to travel to your hand or to your legs to apply that brake is called as volition. So the time taken for the final step of action is called as volition. Now all these things will be happening in just 2.5 seconds. And that's for an average driver. For smart people like you and me, for intelligent people, for experienced persons, this reaction time will be even lesser. So if nothing is given, if nothing is mentioned in the problems, we take the reaction time of the driver as 2.5 seconds. So basically, the distance traveled by the vehicle, during the reaction time is called as lag distance, right? Now, how much is this lag distance? That is the next thing, right? Distance is equal to speed into time. This is a very old formula which we all know, right? So, lag distance. Distance here is nothing but the distance moved by the car, which is nothing but lag distance. Lag distance is equal to speed into time. What is the speed of the vehicle? That is design speed. That is V meter per second. And how much time it has been traveled? Whatever is the reaction time. So reaction time is indicated with T, small t. So lag distance is equal to design speed into T, right? So that's the first part of this example. Now the second part. So after coming to this point, you have decided that you need to apply the brake. Now, at the point just before the application of your brake, what would be your speed? Means what would be the speed of the vehicle at this particular point? It is the same V meter per second. So you have not applied any brake. You are traveling with the same speed. Now, after coming to here, you have decided that you need to apply the brake. So you have applied the brake and the velocity goes on decreasing and finally it stops. So velocity is 0. Now, what can I call this distance as? Very simple, right? This is the distance moved by the car after the application of brake. So I call this distance as braking distance. Right? Braking distance. As simple as it is. Distance moved by the car, distance moved by the vehicle after the application of brake. So that's why it is called as braking distance. Now this is important for us when we are solving some problems. So before applying brake, at that point velocity is the same as design speed, and after application of brake, at the end when it got stopped, obviously the final velocity is 0. Now what comes into picture when you apply a brake? Obviously, if you apply a brake, the force which is helping the vehicle to stop is frictional force, right? So let me consider this vehicle here. It is moving in this direction, right? It is moving in this direction. Let us say the self-weight of the vehicle is W, and as your vehicle is in contact with the road surface, there will be some normal reaction. And in this case, you have applied a brake, right? So if you apply a brake, the force which comes into picture is frictional force, and frictional force always acts opposite to the movement. So as the movement is in this side, I take this as my frictional force. And how much is the frictional force? This we have already discussed, right? During the friction topic or skid resistance topic. Frictional force is equal to coefficient of friction into self-weight. Of course, this is for plain roads. For hilly areas, for upstream or downstream, we'll see a bit later. Okay? So for plain roads, frictional force is equal to coefficient of friction into self-weight of the vehicle. Now, as this vehicle is moving, it has got some energy. So we have only two types of energies, potential energy and kinetic energy. When will it have a potential energy? If the body is in stable condition. If the body is in rest position, it will have potential energy. If the vehicle is moving or if the body is in running condition, it will be having kinetic energy, right? So as the body here is moving in this direction, it has got kinetic energy in that direction. So what I do here is I equate kinetic energy. This kinetic energy here is being opposed by this frictional force. This frictional force. What I do here is kinetic energy here is being applied by this frictional force. But if you see this equation, here you will be having energy, here you have got friction. But equation is not matching because here is energy, here you have got only force. So to make it balance, I take this also as energy. And what is energy? Energy is equal to force into displacement. So force into displacement. Displacement here is nothing but braking distance. Braking distance, right? So kinetic energy is half mv square. And frictional force we have seen just now here, F into W into braking distance. So half M can be written as W by G into V square is equal to F into W into braking distance. So this W and this W gets cancelled, then braking distance is equal to V square by 2GF. So this is how we get the braking distance, V square by 2GF. Now, the total distance here is lag distance plus braking distance. So the total distance SSD is equal to lag distance plus braking distance, that is V into T plus V square by 2GF, where V is design speed in meter per second, T is reaction time. If nothing is given, we should take it as 2.5 seconds. F is coefficient of which friction? Your vehicle is moving in the longitudinal direction of the road. Body is moving in the longitudinal direction of the road. So which friction we should consider? Coefficient of longitudinal friction, right? Coefficient of longitudinal friction. This we have already discussed. Coefficient of longitudinal friction. How much is it value? It value varies from 0.35 to 0.4. 0.35 to 0.4, right? So this is what SSD is, right? So please note it down for 3 minutes. Yes, I hope you have done with the writing part. So that's the formula for calculating the stopping side distance. Now, what we have seen the derivation for stopping side distance. We have seen what is stopping side distance, but what exactly it means? What is the requirement of stopping side distance on roads? That is to be seen, or we can even write the definition for the stopping side distance, please. Stopping side distance is the minimum distance. It is the minimum distance that is required for the driver. It is the minimum distance that is required for the driver to avoid an accident on a particular road. Right? So that is what it means. So what is stopping side distance? What is the example you have seen? First, the driver is looking at the obstruction, looking at an object. He will analyze the situation. Then he will apply the brake and he will stop his vehicle without colliding that obstruction. So the minimum distance required for the driver to analyze a particular situation, apply the brake and stop his vehicle before hitting the obstruction is called as stopping sight distance. So at any point of the road journey, the driver has to maintain stopping sight distance, need to have stopping sight distance to avoid an accident. Now we'll see some of the cases related to stopping sight distance. First one is braking efficiency. Let us say it is indicated with eta, braking efficiency. Now we won't have a braking efficiency of 100%. If the braking efficiency is 100%, that means your brakes are working perfect. And if braking efficiency is 100%, that means if you apply the brake, the vehicle stops there itself. Does it happen? No, right? If that vehicle brakes there itself, if that vehicle stops there itself, that will cause skidding and that will even cause to accident. So we won't generally maintain a efficiency of 100%. Our brakes will not be that much higher efficient. So generally we maintain 70 to 80%, and you should frequently go for the brakes tightening. So now, if the braking efficiency is less, let me write here, as the braking efficiency decreases, what happens to the stopping sight distance? Will it increase or not? The stopping sight distance will increase. Why it will increase? Because the braking distance will increase. After the application of brakes, it need to travel more distance if the braking efficiency is lesser. If the braking efficiency is more, the braking distance will be lesser. So braking efficiency has nothing to do with the lag distance. It only has an influence on braking distance, right? So that's why if braking efficiency is given in the problems, then stopping sight distance is equal to your lag distance remains the same, v into t plus v square by 2gf into braking efficiency. So this is one of the case if the braking efficiency is given in the question, right? Now, what happens if they give you a gradient? Now, this gradient can be upward gradient or a downward gradient. So, if this is a hill, this is an upward, and this is a downward gradient, right? So, now, whether you're traveling on a hill or whether you're traveling on a plain road, does your thinking time change about a particular situation? No, right? So, whether it is a gradient or a plain road, again the lag distance will have no effect over it, right? So, lag distance remains the same. Lag distance remains the same. Now, what happens to braking distance? Is it having any influence? Does it have any influence over this? Yes, it has influence. What? Let us say you're climbing a hill, means you are traveling on an upward gradient, right? So this is your movement. Now, try to mark the various forces on it. So this is W, right? Now we have applied a brake, so there will be a friction here, right? And this W has components. If this is theta, as W is making an angle with respect to vertical, it becomes W cos theta, and this is my W sin theta. And as usual, your kinetic energy will be moving in this side. So just see here, as your vehicle is moving in this direction, kinetic energy is having in this direction. So in this direction, you will be having kinetic energy of half mv square. Whereas here you will be opposing. The kinetic energy here is opposed by friction as well as W sin theta. In the previous derivation, we have seen that kinetic energy is just being opposed by frictional force, but that is for a plain road, as I said. Now this is an upward gradient. So this kinetic energy here is opposed by both friction as well as a component of self-weight. So to balance this kinetic energy, here you have two forces instead of one force in the previous derivation of braking distance. So as you have two opposing forces, so braking distance will be less. If you apply a brake, that stops quickly. Whereas here, now just consider a vehicle which is traveling on a downward gradient. So this is my speed, or this is my kinetic energy. This is the self-weight of the vehicle, right? Now you have applied a brake, so as it is moving in this direction, there will be frictional force here, and it has got self-weight, so it has got components same, W cos theta, and this is now W sin theta. So here kinetic energy plus a component is helping to move, and that is being only opposed by the frictional force. So here two forces are moving the vehicle, whereas it is being opposed by only one force. Therefore, braking distance will be more. Therefore, braking distance will be more. So SSD is equal to V into T plus V square by 2G into F plus or minus N by 100, where N is gradient. You should use positive sign for upward gradient, and you should use negative sign for a downward gradient. That is how we calculate stopping side distance if there is a gradient, right? We can note it down now.